Hello, wonderful learners. Our discussion for today is about the turning effects of forces. Turning forces are found in many everyday situations and are essential for machines to function. Levers and gears make use of these turning forces to provide an advantage. The moment of a force. A force or system of forces may cause an object to turn. A moment is the turning effect of a force. Moments act about a point in a clockwise or anti-clockwise direction. The point chosen could be any point on the object, but the pivot, also known as the fulcrum, is usually chosen. In the picture, the anti-clockwise moment acts downward on the left, and the clockwise moment acts downwards on the right. Making use of turning effects. The moment of force is bigger if the force is bigger. The moment of force is bigger if it acts further from the pivot. The moment of a force is greatest if it acts at 90 degrees to the object it acts on. Using a crowbar to lift a heavy paving slab, pull near the end of the bar and at 90 degrees to have the biggest possible turning effect. Lifting a load in a wheelbarrow, the long handles help to increase the moment of the lifting force. Calculating the moment of a force. The size of the moment of a force can be calculated using the equation moment of a force equals force times the perpendicular distance from the pivot, which is represented by d. Or we can say moment is equal to F times d, where force or F is measured in newtons, distance or d is measured in meters, and moment is measured in Newton meters. In this illustration, the perpendicular distance from pivot to force is equal to 0.50 meters. Force is equal to 10 newtons. Moment is equal to force times distance. Substituting the value for force is 10 newtons and 0.50 meters for distance. Multiplying 10 times 0.50 meters, moment is equal to 5 Newton meters. This is a clockwise moment. The force will rotate the object in a clockwise direction about the pivot. Question. A force of 15 newtons is applied to a door handle 12 cm from the hinge. Calculate the moment of the force. Perpendicular distance from the pivot to force is equal to 12 cm or equal to 0.12 meters. The turning force is equal to 15 newtons. Using the formula, moment is equal to force times distance. Substituting the value, which is 15 newtons for the force, times 0.12 meters for distance, it will give 1.8 Newton meters. So the moment of force is equal to 1.8 Newton meters. A force of 40 Newton is applied to a spanner to turn a nut. The perpendicular distance is 30 centimeters. Calculate the moment of the force. Perpendicular distance from pivot to force is equal to 30 centimeters or 0.30 meters. The turning force is equal to 40 newtons. Using the formula, moment is equal to force times distance. The next step is to substitute the given value. 40 newtons for the force times 0.30 meters for the distance. It gives 12 Newton meters. So the moment is equal to 12 Newton meters. This is a clockwise moment. That's all for today. This is Teacher Rose of Woodrose International School.